Can I go to the toilet?
Yeah, sure.
Wait, but maybe a rectangle? It's like the angles are still basically the same.
Do you know which angles it's talking about? Show me which angles. The diagram's too small. Look at that small. Look at this angle.
Yeah. So is the boundary on the grid? Is the boundary on the field?
So the outside boundary is this no?
Yeah.
That's the fence. But the dividers you can't see it, but it's on the line somewhere. No? Why would you think that's easy? Sense. A, B to D. You didn't understand this thing. You just made this up. question. So have you finished the first question?
I think it's not there because if they jump 2 forward and then they jump 1, the other one can jump 1 back. And if they keep on repeating this, and then it's possible that they can end up at the same square, except not in the same order.
So can you see that you're not drawing it all the way to the end?
Hmm?
Do you think you can do it all the way to the end without speculating? Just come up. This wasn't right.
Do they have to, in the first question, can they get to go back and then go again?
What do you mean by go back and then go?
So getting to or the last one that they end up on, and then going back.
Oh no, they have to end up at 10 only once at the end.
Okay.
They can't they can't go to 10 somewhere in between.
Wait, what was the boundaries for?
AEST. What does this mean?
So, see clear cells and means clear cells on this side, and you've got Maurice's on top. So during the questions from
Yeah.
So
it looks like you need to learn what a proof is. Okay. Writing too many answers,
so
no
1
proofs.
goes to 2, and then it goes back.
That is not.
And then it goes back, and it continues.
Very annoying.
To be honest,
No, but you gotta write a proof. Okay. And I think it's not hard because you didn't understand. It's actually hard for you. The question 2, I see, in difficulty order for you, I think question 2 is probably harder because it's hard to understand what the question is asking. Okay? I think 3, yeah, I don't know. They're all. I think question 1 is okay for you guys, but question 2, 3, 4, 5, you need to work at it. Okay?
Oh yeah, for question
Because a
two.
lot of the time you think you understand the question, but you don't.
Oh yeah, for question two. For question 2,
What are you talking about him?
what the heck is
You can't get
convex?
questions right without proof. Right? Yeah.
What is convex?
As I said, there's 1, 2, 3. They're just going up by 1. How are they different?
Going back.
They can't repeat. Yeah? They're only going to each score once.
Oh.
Michael, what is convex?
What does it mean by this? Counted.
Yeah, if you try 5, you only get 3 scores. I told you only to try 1. You tried all 5. Right. So try the first problem. Right? Actually solve it. In the exam, I think you put like a yes on. Yeah.
You just said, no? Because we can drop in any direction.
It's true. They can go forward. Oh,
Michael, Michael, for question 2, what does convex mean?
what'd you say, Anis?
What does
They be facing different directions when they start?
Can they be facing different directions when they start? No, because you have to go. You're on 1. You have to go forward. Oh, also, Ernest, I would like you if you like go into the room, so you see someone new, like Gabriel, and maybe introduce yourself, okay? So Gabriel, that's Ernest. Ernest, that's Gabriel.
So I think I got the first one. So these are the myths. So they skip 2, so they get to number 3. And then this one goes to 2, this one goes to 4. 2 goes to 4, and 4 goes to 6.
Yeah.
And then 1 goes back and 1 goes forward. So they end up on 5, and after that it's all the same.
Oh, that's very good. Oh, so switch. Very good.
So does it work?
Yeah, I think so. Yeah, what are the conditions you have to check, you know?
The conditions I need to check are, so So I need to check if they can jump to 2 squares.
Yeah, I guess you just need to check that the distances are all the same, which they are, and they don't visit any squares twice. There's all 10.
3, 4, 6, 5. Yes, and 1. Take them discount. No, they haven't.
So how does this person visit 6?
So 4 to 6. They go skips 2, goes back 1. That one goes forward. And then this one, from the starting one 2, goes to 4, and this one goes to 6. Because he was on 4 originally.
Okay, so M goes to 6 like that, right?
Yeah.
How does C get to 6?
Oh, 6. Oh. So he's on 6 right now. I said that's support. Okay.
Titus, do you need more time for the first problem? Need more time, Ernest? That's more paper. No. Alright, there are a couple more minutes. Okay, bro, do you need more time? Few more minutes, yeah? Good, that's a good spirit.
Every time I do it, one of them always gets distracted here, somewhere here, in one of the gaps. Oh. No. Don't think so.
Blake, can you hear me? Alright, nice.
Yeah, I can hear you.
And I'll put that there in case you want to rewind.
I can't seem to do it.
Okay, so I might start talking. I'll give you a little bit of time. I'll get in my mouth. Okay, so if you look at the first question, right?
Yeah.
Okay, so let's just get some things straight because we have some new people here. So you can see it's already very different. Like a lot of other like maths you're used to, you have lots of questions, right? You have to do them really quickly, right? And if you don't do them quickly, it's almost as if like they're wrong because you didn't have a chance to do them. Yeah. You can see here we have only very few problems. Okay, only 5 problems, and even with only 5 problems, if you actually do the test, I just want you to do 1 problem. Does that make sense?
Yeah.
So that's even less, right? It's only 1 problem, and it's all about getting it right. Okay, it's not about the speed. So in this test, you get like 4 hours to do this. Okay, so you had like like half an hour. You know what I mean? There's not enough time, but and I want to tell you this because this is what maths is about. Okay, maths is primarily about accuracy. You understand?
Yeah.
That makes sense. The idea has to be right. Okay. Whereas if you're around a lot of different people, you'll think it's about speed and accuracy, right? But speed only comes into it to break the ties. Does that make sense?
Yes.
If both people can do the question accurately, then in some sense the tie break is who can do it faster. Yeah. But it's a very small thing compared to the accuracy to be able to solve it. Does that make sense?
Mm.
So on a test like this, people are not used to it. They come in, so they write like 1 word for each of 5 questions, okay, and they do that quickly, and then they get 0, okay, and that's and then they also have another 3 hours left to do nothing, okay. And if you think about it, it makes a lot of sense, right? Because if someone in the real world even, right, asks you to do something, okay, so they're like, okay, design for me a spaceship, right? Are they interested, like, and then you come back the next day, like, it's like as soon as they ask you, you just give them a piece of paper. Oh, I've done it. It's finished, right?
I think I got a muscle cramp.
Oh, are you okay?
Yeah.
Oh yeah. Let's try not to. Stretch it out. Is it your calf?
No, it's between these joints.
Yeah. Yeah. Try to stretch it out if you can. I'll put this.
Yeah, second.
Rest on that and stretch it out. Yeah. Yeah. So. Yeah, if someone just give you like if they just like build me like design my house or something like a car which could actually be dangerous if it's wrong, right? And then you just give it to them straight away. Oh, here it is. Here's the car, right? Do you think that they're really happy about making this? Do you think they're gonna be?
No, it could have some mistakes.
Could have lots of mistakes in it, right? So I think someone would be more happy if you went home for like even a year, right?
To make the best car in the world.
And come back with something that's gonna be safe, right?
Yeah.
And for example, if someone just goes like, hey, I want a car, and pays you money and you
Yeah.
make car. If it takes like 1 second only, then probably have like a million mistakes.
Yeah.
But if you take probably really long, it might become the best car in the world.
Yeah, so like if you're quick with mistakes, it's pointless, right? If you're accurate and slow, there's still a point, but obviously it's better to be accurate and fast. But the fast thing is it's not that important. You understand?
Yeah.
The accuracy is what's important. And so a lot of these things that's what proof means, okay? So this is called a proof writing contest, okay? Because you have to prove that you're right, yeah? So in a sense you're marking your own test in some way. Because you're telling them that I'm right. You're not just telling them the answer, you're telling them why you're right. Yeah? That's what a proof is. That makes sense?
So you're explaining the reason why you think it is like this.
Yeah, and the reason is supposed to be convincing beyond any doubt. Yeah? So in principle, like what is accuracy, right? It's like if you put the answer there and you're not sure, then you have not solved the problem. Okay? You might have gotten a good idea, yeah? But you're really asking someone else to help you finish the problem. That makes sense? The problem is finished when you have the certainty. Okay? That sounds very simple, but like there's a lot of things in mathematics that people haven't been sure about like for their entire lives. Yeah? So there's lots of questions in the past people couldn't answer. And they thought it was one way, but other people thought it was the other, and they couldn't agree, right? Even in mathematics, where it's kind of black and white, there was still lots of debate. Does that make sense?
Yeah.
And the reason is because some of the arguments can be very tricky, right? Okay. Yeah. And I think when you're young, it's good to play with numbers and do lots of special cases than to argue very broadly. Yeah?
Yeah.
Because that's the big mistake young people make. So I like the first question. Let's just look at the question. I can't talk too much broad in general, but if you look at the first question, it lets you play with numbers, okay? And actually, a lot of people got this question wrong, especially the older students, because they thought they could argue that there was always the same, and the arguments usually didn't go very well. Okay. So we have like a strip, yeah?
Yeah.
Okay, and it starts at 1, and it ends in 10, yeah?
Yeah.
And we're trying to get to all the numbers, yeah? And if you get to all the numbers and you only have 10 goes, you can't actually get to them more than once, right? And so you have to start at 1 and you have to get on up at 10, right? And the question is, can you do it in more than one way, basically? Yeah. Where each jump basically is either forwards or backwards of the same length, right?
Yes.
So basically, is it possible that if you get there somehow, and at some point you reverse the direction of a jump, yeah?
Yeah.
Yeah. You can still get to the same place using the same length jumps. Okay?
Yeah.
So Ernest, do you have a solution you want to show us?
I think it will.
Oh, okay. Um, okay, so let me show. So actually, it's kind of funny because all the people in high school who tried this got it wrong, okay? The only 2 people who solved this problem were in year 4. Okay?
Wait, was it? Wait, but me and Ernest were only people in year 4.
Lucas is also in year 4.
Wait, Lucas did us.
Lucas did it in Melbourne. Okay, so let me just bring up Lucas's.
Oh, Lucas did it like somewhere else.
He's in another state.
Oh.
Yeah, so I'll show you his paper here. Melbourne is in Victoria, did you not know? Okay, so Lucas, I recommend not writing using the same page to write more than one question. How do we zoom in on this?
So we can go to 0.
Alright, can you guys see this answer?
Yes.
So
You can
Lucas
zoom-
starts
you
on
can zoom
1.
in.
Oh, that's
If
actually
you look
hard
at
to
the
see.
search bar and you
How
go
do
all the
you
way to the
see
right,
this?
there's like a magnifying glass. You can click on it, or you can just use
Maybe I'll just download this
tutorial.
and make it bigger. It's too small.
Wait, so me and Lucas were the only ones who solved it.
Yeah. It was quite poor really, isn't it? I still don't know how you solved it. You gotta tell us how you thought about it, because that's like big surprise for me. Does this get
I
anything?
just tried a lot of examples. And then and kind of found a little pattern and then that's really what? On the
There we go. Alright, that's good now, right? Okay, so one of them starts at 1, right? Yeah. So we can just kind of keep them side by side. We just want to make sure all the jumps are the same and they get to all the numbers, yeah? So they both jump to 2, yeah? Yeah?
Yes.
Then they both jump to 3. Wait, what? No, that's not what it is. At 1. Okay, so they both jump to 3 at the start, yeah? Yeah?
Yes.
I think you got that, right? And then one of them jumps back to 2. The other one jumps forward to 4. Yeah?
wait, this is different. I got a different one.
Yeah. Okay, and then this one jumps back to 2 now, and this one jumps forward to 4, yeah?
Yeah.
So everything's right so far, and they got the first 4 numbers, yeah?
Number 5 is the part I got wrong.
Ah. Okay, and then instead of jumping to 6, they jump to 7, right? They get to 7, and this one gets to 5, yeah? Okay, and then from 5, we go forward to 7, and this one from 7 go back to 5, yeah? So now 6 is the only one that's missing, right? And so this one goes forward to 6, and this one goes back to 6, and then the rest is the same, yeah? You see that? Okay, that's very good. Yeah.
But before we saying that high schools who did this didn't get it, only one and then 2.
Yeah, I mean, the statement is not completely accurate because a lot of the high school people, they skipped it as well. Okay, because it's 5 questions, you only can do 3. Okay,
So just some of the high
Wait, you can only do 3?
well, you can do as many as you want, but only 3 counts. Okay, and I'm constantly annoyed when people do more than 3. Okay.
Yeah.
Okay. Did you want to see Michael's solution?
Yeah.
See if it works. Yeah, I think it also makes a difference which way you go, because if you're looking for an example, you'll probably find it, okay? But a lot of people trying to prove that it always is the same is going to be very difficult. You understand? So you have to imagine, okay, so does this work? So you have, first one goes to 3, yeah?
Yeah.
The other one goes to 3, then back to 2.
Just one.
That one goes forwards to 4. Wait, what's that? This one goes forwards to 3, then to 4, yeah? This one goes to 3, then back to 2, yeah?
Yeah.
And this goes forwards to 4, and then this one goes back to 2, right?
Yeah.
And then 2 goes forwards to 5, and the 4 goes forwards to 7, yeah?
Yeah, and then they both go on 6.
And then 7 goes.
Wait, actually, they swap positions and then they go on 6.
Okay, so then from 7 it goes back to 5, and from 5 it goes forwards to 7, yeah?
And then it goes pushes.
And then from 7 it goes back to 6, and from 5 it goes forwards to 6, yeah?
And then they move 2 steps to 8.
And then they both, and then it's the same from then on, yeah? 8, 9, 10. Okay, so that's very good. It's kind of a similar idea towards the end, but it started a bit different, yeah? Wait, did it start the same?
Well, kind of.
Pretty much.
Was this the same solution or different? So this is a test of your memory.
Wait, like
Yes, it was
like
the
Lucas
same.
and mine.
Yeah, is it identical or is it different?
I
The
think
start.
I think it's a little different.
So
I think it's identical. Yeah.
remember the start? I didn't read the start right, yeah?
It's the same.
Okay, I'll put Lucas's up. Goes to 3, back to 2, to 4, 7, 5, 6, yeah?
Yeah, so that's
Then
the
there's
same.
3, 4, 2, 5, 7, 6.
Yeah, it's
Yeah.
the same.
It's exactly the same, yeah. Okay. So, and also if you're at home and you like the problem, you don't have to settle for just finishing the problem. You can actually be like, what are all the possible examples of that disprove the problem? You know what I mean? You can extend the problem a lot more because we do it out of curiosity. Does that make sense? It's not just solving it because we're trying to get marks and trying to win a competition. We're actually trying to be interested in the maths. Okay? Yeah, and this way of doing it actually makes you better at maths in the long run. Okay? And so why should you listen to me, and why you don't why would you listen to me when other people are saying different things? I guess the difference is I can actually solve the problems. Okay? And I've done a lot of maths. Whereas other people, they can't solve the problems. They look at the answers and they give you advice. Okay?
Yeah.
All right. So the next problem I want to look at is this problem. Okay. So I'll give you a little bit of time to think about it, but maybe I'll already give you. So if I explain what the problem's asking, okay, in this context for you guys, I'm actually helping you solve the problem. Does that make sense? Because part of the problem is to understand the problem.
What is a polygon?
Yeah, what is a polygon?
5 sides.
Okay, so what's a polygon? So a polygon is like, let me just draw something. Yeah, so it's funny you go to answer him, but you don't necessarily know what it is. So I think it's a good question. So this is like a polygon. Actually,
Polygon where all sides are equal.
no. What does polygon even mean?
Oh, that's a
What?
A polygon is
Okay.
5-sided shape.
You should think before you say you know what it is, not after. Okay. Alright. So that's like a polygon. So polygon, what does poly mean? You know? What does poly mean? Yeah, I guess what poly means can be confusing if all you learned is Pokemon, right? But like poly means like more than many, yeah? Right? Multiple, yeah?
That means it's a shape of a lot with a lot of edges.
Yeah, so gon is like
Hexagon.
I guess it's like points, yeah? So it's a shape with lots of points. You see?
Is this
So a trigon, I guess, would be like a triangle. Yeah. Yeah.
Lots of points.
Does that make sense? A triangle. So polygon has lots of points. So as far as we're concerned in primary school, points and sides. So a polygon has lots of sides. Yeah. There's no difference. Okay. Yeah. So actually, this brings. I want to maybe while you're asking about polygons, then maybe we can talk about this question for a little bit. Not the answer, but the question that came up was, what does convex mean? Okay. What does the word convex mean? So the word convex is here. Yeah. What does convex mean? Okay, so I'll give you two definitions, okay? One definition is if I take the angles inside the quadrilateral. The quadrilateral is another way of saying quadrilateral is four-sided shape, yeah?
Yes.
A tetragon, yeah? Okay. The angles inside have to be all less than 180. Does that make sense? So is this shape convex? Is triangle convex?
Yes.
Yes? Huh?
So every angle added up has to be less than 180.
No. Every individual angle is less than 180.
No.
What is not? The triangle.
It is convex.
It is convex.
It is, right? Because if all of them are 180, then each one is less than 180, yeah?
Yeah.
So this is convex, yeah?
Yeah.
Is this shape I draw convex?
No,
Why not?
because on the very edge, so it goes like this.
This angle, right?
Yes.
Yeah,
That's like 270, right?
Yeah.
So this is not convex, yeah? Okay, let me give you another definition of convex, okay? So I have a quiz for you. So I need Lucas to actually use your microphone to answer me after this, okay? So I'll give you another definition of convex. So convex, if I draw two dots inside the shape, okay? And I join them, okay?
Yeah.
Then the segment that I joined the 2 points, the straight segment, right, is also inside the shape. Okay? You see, if I put 2 points in the triangle and I join them, it's also inside the shape, right?
Yes.
You see, if I put 2 points here, yeah, and I join them, it goes outside the shape. Yeah?
Yeah. So it has to be straight. It can't be bent.
Yeah, it can't bend inward. It can only bend outwards. Like it can only bend out this way. It can't bend inwards like this way. Yeah. Okay. So my question to you is, what's the difference between those two definitions? Are they saying the same thing? Like, can I say one definition is better than the other?
No.
Be careful when you say no, okay? Because sometimes it's not as straightforward as yes or no instantly, okay? Yeah, this is actually a very difficult question for you guys, but it's a question you can understand, right? Yeah.
I can understand it.
Yeah. See,
Inside, or can it be on one of the lines?
the 2 points have to both be inside.
Inside. Can't be on the line.
No. I mean, like, a point that's inside and a point that's on the line, like a point that's really close to the line and a point that's on the line is not really that different. You know what I mean?
Even if I don't understand it, I can get up to it anyway.
Huh?
Even if I don't understand it, I didn't get up to it anyway.
No, that's not the right attitude. You understand? You can't lose 100% if you lose 10%. Okay? You gotta try to get as much as you can. Okay? Everything you understand now, you'll save like a lot of effort later. Okay? Even if you don't understand it completely. Okay? A lot of the time at school, they teach you nothing and you understand it completely. But here, I teach you a lot and you probably understand 20%. You know what I mean? But that 20% is more than 10 times what you learn at school.
So one of them is talking about the angle, So the first one.
Yeah.
And the other one is talking about joining two dots together
Yeah.
for a straight line.
Yeah.
So if it's convex, it has to be inside the shape.
Yeah. Okay, so let me give you one idea why one definition might be better than the other. Okay, but it's better depending on what you're doing. Okay, it's not always better because if we're talking about a polygon, right? I think the angle definition could be better because you can understand that really easily, right? Yeah. Okay. But in other situations, for example, look at this. What if I draw a circle? Yeah. Is a circle convex? Yeah, so the first definition no longer works, you see, because it doesn't have angles, right?
It doesn't have the edge.
But you can still talk about it being convex if you have that the points definition, right? So that's the difference, right? Like one definition can let you change your situation, okay? But it's actually more difficult to understand for this situation, yeah?
Yeah.
But the other one, it works very nicely for this situation. It's very simple, but it doesn't work when you get to here, yeah?
Yeah.
So in some sense, you can think of it in two ways. You can think of that as the proper definition, and it specializes to this, and you can understand this for this case. Or you can think of this as a definition, and it generalizes to this other situation. Okay? So maths is about dealing with general and special situations. Okay? Moving with ideas. Yeah. Make you think, right? Okay, so it's kind of crazy. Okay, so back to the farmer question. No?
Does convex work if, for that circle in the second definition, does convex work if there's a smaller circle inside the normal circle?
So you mean if it's like a hole?
Yeah.
Like a donut?
Yeah.
Yeah, so if you got a hole in it, it's no longer convex, right? Because now, if you join 2 points, it goes outside it, yeah? Yeah, good. So this is called an annulus. An annulus is not convex, but a circle is, okay? And the fact that you can even talk about convex for these weird shapes is a testament to this definition, okay? Okay, so like, yeah, so this is like mathematics is a lot of it is realizing when things are the same or when they're different, you know? That's fundamentally what logic is. And so most people don't actually appreciate it. They're like, oh, Olympiad math is different from school maths. But they're saying it in a naive kind of way, okay? Whereas in some sense, I like to say it's the same, but it's the same in a different meaning than the way they're saying it is different. Okay, so what's the farmer question? Okay, let's look at the farmer question. Okay, I'm not going to draw everything, but I'll draw hopefully enough. So you got these grids, right? Okay. And there's 8 rows and there's 8 columns. Yeah?
Yeah.
Okay. And so there's 64 squares altogether. Yeah?
Yeah.
And each farmer owns 8 squares. Okay? But the 8 squares they own have to be in a polygon. Okay? So for example, like they can own like this 1/8 strip here. Yeah? But they can't own like 1 square here and like 7 squares here. That makes sense?
So it has to join.
It has to be a one shape, yeah?
Wait, so can I go diagonally?
No. I mean, it's a polygon, yeah? Polygons, like, it's not clear what happened here at a polygon, right? So polygons are like this, as I was saying, it's like this, yeah? But it's not like, this is not a polygon. Yeah?
They're not joined.
Okay. Alright. Okay, so do you guys understand what the question is asking? So we know that the farmers have 8 squares in a polygon, but we don't know where, yeah? Because they never bothered to mark out their fences inside the shape, yeah? Okay. And we can pick any point here, and there's a berry on it, yeah? And the question is, can we pick 9 points, yeah? So that no matter how the farmers are actually divided up, no 2 of those points are in one farmer's land, yeah? Yeah. I mean, it's kind of funny, right? Because, like, if you think about the problem, if you actually think about it, like, there's actually infinitely many berries, so why would a farmer care if you take 2 of them, right? There's actually, like, so many berries left over, it doesn't matter, okay? But it still makes for an interesting question, because, like, you don't know where the farmer's lands are, right? So how can you guarantee that the berries aren't in their land, yeah? Okay. That's pretty cool, right? And so one key thing in the problem is if the farmers, like, if this is the boundary, so let me draw the boundary in red, yeah? So if this is the boundary of one of the farmers, 2 farmers' land, and the berry is on the boundary, then neither farmer will notice, yeah? It only notices if the berry's inside its land, okay? That makes sense? Like, the berries on the fence don't count.
Would the crow take the berries on the fence?
Yeah, but they don't know where the fences are, right? Okay. But we know that the fences have to lie on the lines, right? Yeah? So that means if we want to try, we might want to try to find them on the lines, right? Yeah? Does that make sense? So if we try to find them on the lines, there might be a chance that it's on the boundary of one of the fences, right? And then it won't count, yeah?
So wait, so we have to try to get the berries from the ground.
We have to find out where the boundaries are.
So you don't have to, okay? So be careful when you say have to, okay? Because you say have to, it's a claim, okay? So there's actually no way to find out where the boundaries are, right? Yeah? So then, in some sense, you have to assume every possibility is possible. So if there's one possibility that makes your thing not work, then your thing just can't work, right? So you have to account for all the possibilities at once. Yeah? Okay. Okay, but this problem has a really nice solution, okay? And I want to show you. This is a very nice problem, okay? And the reason why I like this test is because it has basically the nicest problems in the world. Okay? Okay. So let's focus on just a little bit of the thing. We don't have to look at everything, yeah? So just focus on this top right area for me, okay? Alright. So let's think about this. What if I picked a berry and I put the berry in blue, yeah? What if I picked a berry here? Yeah, does that make sense? So there's 4 squares right next to it, yeah? Yeah. Okay. So the berry could be on like a border, in which case that's good for us, right?
Yeah.
But it's bad for us if the berry's inside some farmer's land, right? Because if it's inside some farmer's land, there's a chance that another one could also be inside the same, right? Okay. So can you see what actually happens if this berry is inside a farmer's land? Can you see? Okay, check this out, okay? If that's inside the farmer's land, right? Can you see that that means all 4 squares have to be inside the farmer's land? Does that make sense? Yeah?
Yeah.
Because if you're missing one of the squares, then this is on the edge, right? Yeah? So for it to be actually inside, it has to have all 4 squares for it to be inside. That makes sense?
Okay. That means, does that mean so every farmer owns 8 pieces?
Yeah, every farmer owns 2 of these kind of things, right?
That means it can only go
That's
across
half.
the gap.
Yeah, exactly, right? So if you look at this, if you take something that's a little bit further away, right, down here, yeah, it can only, you have to own these 4 squares, right? Yeah. So the farmer can't own both of those lands because then he would get 8 squares that aren't connected up like a polygon, right? That makes sense? So you just have to pick the berries that are 3 apart, yeah? So that's 1, 2, 3, yeah? And you know that they'll never be in the same farmer's land. Does that make sense?
Yes.
It's a pretty good idea, right?
Yes.
Yeah, like
Yes.
so that means if as long as you can place the berries in these kind of patches, right?
Yeah.
Yeah. Then the crow will win, right? So can we check that that's possible to do? Um, so if you look at this, it's like 1 square, 2 squares, 3 squares, 4 squares, 5 squares, 6 squares, 7 squares, 8 squares, right?
How
So
many
that
times
actually,
can we do that?
it just fits on the top, right? So the question is, can we just fit it? So if it's 8 by 8, so if it fits that way, it should also fit down this way, right? Yeah. So we actually get 3 by 3, right? That's 9. Does that make sense?
Yeah.
So if we pick these 9 berries, okay, oh, Lucas is drawing it up.
Who's Lucas?
Oh, Lucas is from Melbourne. He's online. He's on Zoom. Oh, Lucas said he just found the answer. Huh. It's got 7 squares there. 7 by 8, 8 by 7. Yeah. So can you see that's kind of nice, right? That's what kind of makes these poems very nice because the solution's very brilliant, right? And it's very easy to understand, yeah? But the whole point of it is to come up with it. Yeah? Okay. Okay. It's almost 6. Ah, see, Lucas is drawing that. You know? And that makes it very clear you can.
Yeah, but can you get more than 9 berries?
You get more than 9. I don't think so.
Can
I
you
mean,
get less than 9?
you can obviously get less than 9. You can get any number of those berries. Yeah. Yeah. I mean, I don't know. Maybe you can have a clever way to get more than 9. Um, it's not obvious if you can get more than 9 from here, but that's a good question. Yeah, you can try to answer it. Yeah. So obviously this idea ends at 9, right? But there might be another idea because there's sort of ways for the berries to be close and they can't have a. Let me show you something as well. This is an interesting idea. Okay. So Lucas, I'm gonna borrow your diagram for a second. Okay. Okay. For some reason I can't hear. Lucas, can you talk? Were you talking? Because I couldn't hear you. Anyway, so I'll give you another idea. Okay. So this idea is pretty good. And so actually, there's a senior problem version of this where you have 9 by 9. Okay. So let me show you an idea that's pretty good. So imagine if you had 2 here. Okay. So maybe Michael, with this idea, you can get more than 9. Okay.
Yeah.
So if you take these 2 squares, let's see. So if you take these 2 squares, right? You know, you'll be like, okay, well your idea doesn't work, right? Because I can draw this square, and I can draw this square, yeah. And it's a polygon, right?
Yeah.
Okay. So this could be actually a farmer's plot, right? That could be their land, yeah? And then it'll contain
What
both
about the
berries.
remaining 2?
Okay, yeah, so Gabriel makes a very good point. There's these 2 squares here that is now can't be connected to anything. It's useless squares now, right? So these 2 can't actually be in the same plot even though they're close together, see? Because to make it, you have to cut off this 2 which can't be anyone, right? So if you put these 2 instead of like that one and that one, you could probably get more than 9, yeah?
3 by 3 and then that square which was.
So again?
Can't you put like a 3 by 3 minus that one square?
3 by 3 where? What are you talking about?
So like 3 by 3.
Yeah, but then the thing is not on the inside. Remember we said for this to be on the inside, we need all 4 squares. Like then it'll be on the edge, right?
But it would make it to
That doesn't exist. I'm not talking about that.
Oh.
I'm talking about the 2 green dots. Yeah. Does that make sense?
Yes.
Okay, so it's a lot of ideas which are very nice. Okay, so the fact that the easy idea works is what makes this sort of like an easier problem. But like, if you think about it, these problems are designed for students from year 7 all the way to year 10. Okay, and but realistically, I think first question is doable in primary school. Second question, if it's not geometry, there's primary school students who can do. So, for example, a student in year 6 could do question 1 and question 3, okay? And that's like the best performance. Very unusual for year 6, okay? A student in year 7 managed to solve the last 3 problems, but with mistakes and couldn't write it up properly, okay? But our students in year 10 or 9 can solve these questions perfectly. Okay? But you got to start somewhere, yeah. And
Do you know the answers?
what do you mean? I told you I knew the
Have you
answers.
solved
I didn't solve them because they've already been solved.
all?
My students solved them. You understand?
Um,
But yes, I could solve them. Okay, let's look at this geometry thing, okay? So actually, this is also one of the very interesting things about these kind of problems is they ask you if it's true or not, right? Instead of a lot of the time when it's a proof question, they actually tell you what to prove as well. That makes sense? Yeah. So this is what makes you think maybe you don't need to provide a proof because half the effort is figuring out if it's yes or no, right? But you have to explain why it's yes or no. Okay. Okay. So we know what a convex quadrilateral is. Yeah. Do we know what parallel means?
So two sides need to be the same.
So parallel means like they're going in the same direction. Yeah.
They can't be going into each other.
Yeah. They'll never meet. Yeah. So it looks like it's gonna meet, but that's because I just drew it bad. Okay. And we draw it like this. And draw it like this. Okay, and then it's A, B. Yeah, so apparently we told the teachers do this kind of stuff so it slows the class down so you can follow. If it was about the speed, it could just load the diagram up. Yeah. So angle DAC, okay? So this is where like you gotta know the definition, or if you guess, you should guess reasonably, okay? You can't just make stuff up. It's DAC. So look, it goes DAC. Yeah? That's the angle. Oh. Yeah, you ask at a really bad time, yeah? You ask in the middle of the question, it's really annoying. That's sad and selfish.
Oh, so it's like three
Go.
angles.
It's only one angle. DAC equals A B ABD, yeah? Right? CAB equals DBC. So it's very simple how the angle works. It's just three letters. It's the one in between. That's the angle, right? So CAB is this angle here, right?
Yeah.
Okay. So someone tell me what DBC is, not Ernest.
Like at the right, top right.
Huh. I feel like there's a typo in the question. DAC ABD CAB DBC CAB DBC. So where's DBC, huh?
At the top right.
Where?
Like the,
That bit? Yeah?
yeah, there.
Yeah?
Yeah.
Okay, and then when we say the lines are parallel, we usually use this kind of symbol here for parallel. Yeah? Have you seen that before?
Yeah.
So you in the school curriculum, you learn about parallel lines in year 7. Okay.
Okay.
Okay, but that's somewhat ridiculous. Okay.
We started learning them this year.
Yeah. Okay. So you learn some more things about parallel lines in year 7, and you know that the angles. Have you learned about the angles in parallel lines?
No.
I
Yeah.
just learned about angles and parallel lines separately.
So for example, if you have an angle here, it's equal to this angle here. It's called alternate angles on parallel lines. Yeah.
So what the alternative? So would it be the alternative
Exactly.
for
Yeah.
A be on the
It's like here. Yeah.
Yeah.
Okay, but this angle doesn't count because it's not with the parallel line. Yeah. So none of these two lines are the ones parallel with the other lines. Yeah.
Yeah.
Okay. So yeah. So it's interesting, right? Okay, so you either have to prove it's a square, okay, yeah, which is going to be very difficult for your age, or you draw a shape that's not a square and it has that property, right? Does that make sense?
yes. A square is completely parallel.
Hmm?
So a square is completely parallel, right?
So square is not only just parallel, but the other sides are also parallel, and the side lengths are equal, and the angles here are all 90 degrees. Yeah. The 90 degrees is this square symbol here. They're called right angles. Yeah.
Yeah.
So one thing you might say, if a four-sided shape has all the sides equal length, is it a square? Why not? Yeah, it's actually a rhombus. Okay, so a four-sided shape, it could be a diamond. It has all the sides equal in length. Yeah, but it's not a square. See? You understand what I'm saying? Yeah. Okay, you can start eating something. We'll get you a plate.
Okay, thank you. I'm okay.
All right. So there's actually quite a lot of things that um go into this. Have you heard of a trapezium?
Yes.
So this is a trapezium, yeah?
Yeah.
Okay, but there's a bit more to it than just being a trapezium. This is what's called an isosceles trapezium. Okay?
I've heard isosceles, except
So what have you heard of
don't
isosceles?
I don't remember it. I only
So the word
remember
isosceles, you probably hear isosceles triangle, right? So isosceles triangle is something which has a triangle and the angles are equal. Right? Yes? Okay, and because the angles are equal, the sides are also equal here. Yeah? Yeah? So what an isosceles trapezium is, it's like
they're all the same.
it's kind of like it's like this, okay? These angles are equal and these sides are equal. Yeah? And actually these angles are also equal. Okay? Yeah. And actually, so maybe one way to relate the two ideas is an isosceles trapezium is really just like an isosceles triangle that's been cut, like the top's been cut off. Yeah.
Yeah.
That makes sense. And now it's like it's missing the top of this. It's actually, it sounds quite cruel, huh? Cut the triangle up. Okay, so but one special thing about isosceles trapezium, okay, and this is something that it's going to be very difficult for you to understand in your first lesson, okay, is that isosceles trapezium lie on a circle, okay. So if you draw a circle, you can actually draw it through all 4 points.
It's kind of like a
Thanks, Michael, thanks. Everyone always says that when I try to draw a circle. Okay. So you can actually fit all 4 points onto a circle. Okay. And the way that you can tell that happens is we know that these two angles add up to 180 degrees. Okay?
Yeah.
And the reason they add up to 180 degrees is because these two angles add up to 180 degrees. Okay? So if you have parallel lines, right? Yeah?
Yeah.
And then you have another line, yeah? You see these angles are equal, right?
Yeah.
But these two angles are equal, yeah? But if they're equal, then that means this one, see this one here adds up to 180 with that one, because it's a straight line, right?
Yeah.
So that means the dot has to add up to 180 with that one, right? Okay. And so this thing adds up to 180 with this thing, right? But that thing is the same as this thing, so that thing also adds up to 180 with this thing, okay? Okay, and why is that special? It's because when you have a circle and you draw 4 points, okay, yeah, and you cut the 4 points, if you take the center of the circle and you join it to the 4 points, do you know that these are isosceles triangles?
Yeah.
Because the center of the circle is the same distance to all the points, right? That means this distance is the same as that one, right? This distance is the same as that one, okay? So that means this angle is the same as that one, right? And that angle is the same as this one. This angle is the same as this one. And this angle is the same as that one, right? Yeah? Okay, so can you see there's 2 of every angle around, so there's eight angles to add up, right? But 2 of them, there's only 4 different angles, so okay. So, do you know that in a quad, angles add up to 360? You know that?
Yes.
Okay. So all of these 8 angles add up to 360, right? Yeah? But all of these 8 angles is just 2 times these 4 angles, right? Because 2 of each, yeah? So that means these 4 angles add up to 180, right?
Yeah.
Okay. And so that's what I mean when I say this add up to 180 makes this on a circle, okay? I'm saying the converse of this, okay? So because if I have a circle and I have a quad, these angles add up to 180, yeah? Okay. I'm also saying that if I have a quad and these angles add up to 180, they lie on a circle, okay? Okay. Alright, so another kind of crazy thing about angles lying on a circle is if you have what's called the bow tie theorem, okay? So if you have a circle, yeah, and you have an angle, okay? You have an angle on the circle, yeah? So I'm talking about this angle here, okay?
And the outside.
If you make the same angle, if you make the angle with the same 2 points down the bottom, so if you take that point down the bottom, and you take this other point down the bottom, yeah, then this angle is the same as that angle, okay? So that's something I'm telling you is true, but I haven't told you why, okay? Just kind of like how you don't know why angles add up to 180 in a triangle, okay? So I'm telling you that when you have a circle, the two angles like this are equal. Make sense? Okay. Yeah. Okay. So see if you can remember all this stuff, because this is what I'm going to use to prove this question, okay? So what I want to do is I want to make a definition, okay? Understand? So I want to make a definition that is easy to understand, okay? So first, let me draw this step. Like I get a line, yeah, okay, and I want to put points A, B, on a line, okay, yep, okay. Then what I want to do is I want to draw 90 degrees, okay, here. So I want to draw another line, and the angle of this line is 30 degrees. Yeah? Okay, and then I want to make this line 60 degrees, okay? And they're gonna meet somewhere, right? Okay, what angle is that angle? Level 14. Okay, so what angle is this angle?
A right angle?
It's a right angle, right? That up to 180, yeah?
Yeah.
Okay. So now let me do the same thing on the other side, okay? I want to draw, instead of 30 degrees on the left, I want to do 30 degrees on the right, yeah? That makes sense? So this angle here is 30 degrees, yeah?
And the other one is 60.
And the other one is 60, right? But instead of writing 60 and making this diagram ugly, let me just write the angle here. What angle is here? 30? Yeah, because the whole thing is 60, right? That makes sense? Yeah? Is that right? Okay, and what angle goes here? 30?
Yeah, 30.
Yeah. Okay, and then what angle goes here? 90. Yeah? Okay, and I want to call this point C. I want to call this point D. That makes sense? Okay. Go. Thanks. No. So, if you want to eat something. Oh, okay. Thank you. Okay, so if I join this line here, right? C and D. So I joined that, right? Okay, if I were to say that ABCD is the thing that I wanted to prove the question with, What would I need to try to check? What would I need to check for this to be... So is it clear that this is not a square?
Yeah, it's more like a isosceles.
Yeah, it's not a square, right? Why is it not a square?
So not all of them are parallel.
Right, yeah, so that's probably the more obvious one. So this one you're saying is not parallel to that one, right? Yeah. And also, saying this one here is 30 and 30, that's not 90, right? So that's not a square, okay? Okay. So if this is not a square, and it satisfies these conditions, yeah, can you see that that would answer the question, it's not necessarily a square, right? Okay, so that's what we want to do, okay? Alright, so what do we need to check though? What do we need to check? Yeah, so which angles are correct? Yeah, very good. So what's DAC? DAC is 30 degrees, right? And what is ABD? So can you see ABD is the red 30 as well, right? Okay, so this condition is true, yeah? Yeah? Yes? Alright, what else do we have to check? Okay, so what's CAB? C... You say 90 degrees? C... A... B. 30 degrees. It's purple 30 degrees, yeah? Okay, so this is 30 degrees. Okay. And what do we have to check it's equal to? DBC. Okay. Okay, so D B C, right? So this is the other red 30 degrees. Yeah. So that's also true, right? Yeah. Okay. So what else do we need to check? Okay, good. You want to check that AB is parallel to CD. So how do we check that? How do we check that? So how do we check that CD is parallel to AB?
You could draw a line to the end and see if they meet.
Okay, but what if they don't meet? Then we may never get to the end. So I guess we could draw it far enough and have a. So this is I guess it's called experiment. Yeah. So we could experiment and draw the lines and see if it looks like they're gonna meet. Okay. And that'll give us evidence for whether or not they should be parallel, right? Okay. So let's suppose I did that and I drew the lines very far, okay, and they don't look like they're going to meet, okay? So now I want to prove that they won't meet, okay? So I guess if you remember what I said a few moments ago, if you have parallel lines, right? So one way to show they're parallel is if you have like a line like this. What are they called? You know? This one, right?
The other one, and
yeah, and then this one is equal. Yeah, so here we have alternate angles, right?
Yeah,
so if we can show like, so can you see which angle is alternate here? If we want to show it's parallel. So we want to show this line here is parallel to this one, right? Yeah, exactly. So CDB is this one, right? Yeah. DBA, yeah. So if we can show this angle is 30 degrees, yeah, then we show that they're parallel. Yeah? Okay. So this is the part where it's going to be a bit tough because you have to remember what I was saying just before, you know? But if you remember what I was saying, do you remember I was saying that if we can show these 4 points here, if we can show these 4 points along a circle, okay, yeah, oh, that's like the best circle I've ever drawn. Actually, the best circle I've ever drawn. Thanks, Michael. Yep. Alright, so not as much anyway. Okay, excellent. Okay, so can you see if I draw that circle, right? Then this angle. Remember when I said you have a circle, the angles. Okay, that's a bad line. Control Z. So if I look at this angle here, yeah, that goes to C, right? And this one goes to B, yeah? That goes to B, yeah? Okay? But this purple angle also goes to C and B. You see that? See that?
yes.
So if they're on a circle, then the purple angle equals the green angle. Yeah? You see that? See, because the purple angle also goes to starts from the same two letters, C and B. Yeah? That's the thing I was saying is called a bow tie, remember? Yeah?
Yeah.
Okay, so this angle is actually equal to 30 if you can show it's on a circle, right? Yeah? Well, can you see that we know it's on a circle because we have actually the same two, we have another two angles which are equal. See the 90 degrees here and the 90 degrees. You see that?
Yes.
So those two angles are already equal, yeah?
Yeah.
And they stand on A and B, yeah? And this one is also 90 degrees and it stands on A and B, yeah?
Yes.
So then, by the opposite reasoning, so what's called the converse, these 4 points lie on a circle, okay? Because the 90 is equal to the 90, okay? And now that we know it's on a circle, okay, we can say that this purple angle is equal to the green angle.
Yes.
Okay? So this is getting very tough, but we're almost there, okay? So if this purple angle is equal to the green angle, then what angle? What's the value of the green angle?
3.
It's 30, right? Okay. And so if that angle is 30, then what have we achieved?
So we know that DBA is also 30, and we know
So dBA is this one, yeah? So we know this is 30, and now we know this is 30, right?
which also proves that that is a parallel.
Now it proves it's parallel, right? Yeah? So we just literally proved that this angle here is equal to this angle here, right? So they're parallel, okay? Okay. So, are we finished? Have we checked everything? What? You can't just say no for no reason.
You have to check it's not square.
Okay, how can we check it's not a square? I thought we already checked it was not a square, because you already said it wasn't 90 degrees and Gabriel said it wasn't parallel and stuff. Yeah? Okay, so it's the easiest way to check it's not a square is to see that they're not 90-degree angles, right? Okay, is that everything? So we checked that the angles are equal, the two angle conditions are true, right? We checked this parallel, yeah?
Yeah.
And we checked it's not a square, yeah?
Yeah.
So are we finished? Hey, convex. We spent a bit talking about convex, right?
Oh, yeah.
Convex.
Okay,
So how do we check if it's convex?
Okay, so one of the angles, they can't be bigger than 180.
Yeah.
Because none of the sides are curved.
Yeah, I like what Gabriel was saying. So they're not more than 180. How can we see that they're not more than 180? So let's try to check it, yeah? So what angles do we need to check, Gabriel?
A, B,
Check the larger angles first, which is
A,
and C.
Okay, what about angle D? What angle is that?
D,
Like this angle here, right? That's angle D, yeah?
yeah, it's not more than 180.
Yeah. But you can actually know exactly what it is, right? Because it's 90 plus 30, yeah? Which is what 120, yeah?
Yeah.
Okay, what about this angle here?
That's also one thing. Because if you add all the other angles up, and then
Yeah, so this one's also 120, yeah?
Yeah.
So for the same reason, this one's 120. Okay. And what is that reason, do you know?
you can do the same thing. Any angle C, which is not the right angle.
Yeah,
You can do that for the green angle.
like the bow tie thing, right? Okay.
And then
Or you can just do the angle sum of a triangle now, yeah? Okay, so these two angles are the 120, they're not more than 180, yeah?
Yeah.
What about the other two angles?
they're even less, and they're even less than the other angles, and the other angles are less than 180.
Yeah, so these are even less because they're even less than 90, right?
Yeah.
Okay, so then are we done? Have we checked everything?
Yeah.
Okay, well done. Yeah, we checked everything, right? There's nothing else. It says convex, parallel, angle, 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 and then it's not a square. Yeah? So that proves it. You see?
Yes.
Yeah. So even a lot of really good students couldn't do this, okay? Because they made all these general arguments, okay? And they didn't produce an example. Understand?
Yes.
So the whole point is if someone talks a lot of crazy at you, and you don't understand what they're saying, it doesn't necessarily mean they're right. Yeah.
Yeah.
Okay. Sometimes it's when you actually understand what they're saying and it's simple. That's when you know they're right. Yeah. Okay. And sort of as mathematicians, our job is to make it simple for other people. We take the complicated thing and we produce something simple. Does that make sense? And that's the result of having understood it. Yeah. Okay. All right. So that was pretty good. I didn't actually expect you guys to get this far. Okay. It's good that you have. It's only going to get harder from here. Okay. Okay. So we're up to the fourth problem now. Okay. So the question is, do you even understand what the fourth problem is asking you? Do you understand what the fourth problem is asking? So I'll give you like a bit of time to try to understand it. But trying to understand the question is actually part of the problem solving process, okay? So if you don't understand the question, that's sort of the point, you know? Actually, I have the exam in Russian, and you can see the Russian version of the question, and you can't understand what it's saying then, right?
I think it means like there are numbers in a circle. Each two numbers, if they're next to each other, one must either be twice as big or five times as big as than the other one.
Yeah.
And all of the numbers, can all of the numbers equal 22?
Yeah. So can all of the numbers sum to 2022?
Yeah.
So like, let me draw a circle. Like the circle is not important. It's really that they're just in a ring, right? So if I have a number like 1, okay, the number next to 1 has to be either twice 1 or 5 times 1, okay? Obviously, it has to be a whole number, so it can't be half or a fifth, yeah? So let's say 2, yeah? And let's say the next number is 10, yeah? Okay. And let's say this number is 5, yeah? Can you see this satisfies the question, yeah? Because this has like, this one is twice 1 is 2, 5 times 2 is 10, 10 is 2 times 5, and 5 is 1 times 5, yeah? Okay. But what do they sum to? What do they add up to?
18.
18, yeah? They add up to 18. Okay, and 18 is not 2023, right? Yeah? So this is an example where it satisfies the first one, but it doesn't satisfy the conclusion, right? But it's not asking you the same thing that this one was asking you, right? It's not asking you, is it necessarily adding up to 2023, yeah? It's saying, can it ever add up to 2023, yeah? So it knows that it's not going to add up to 2023 very often, okay? Like I'm going to need a lot more numbers before I add up to 2023, right? But the question is not asking me if it can not add up to 2023. It's asking me, will it ever add up to 2023? Yeah? Like if I try my best and do all the numbers in the world, right?
Yeah.
Is there one way I can, like, with all the luck in the world and everything on my side and intelligence, can I get it to add up to 2023? Does that make sense? Or is it not about how smart I am? What if it's just impossible? Yeah? What if no one could do it? Yeah? That makes sense? So that's what the question's asking.
I know an impossible question.
What?
I know an impossible question.
You know an impossible question?
Yeah.
Okay.
Once I was asked, what's an animal with 3 legs and 1 tail? But when it goes to sleep, it only has 1 leg and 4 tails. What is the animal? And then I searched that up, and then it said, there is no answer to be found.
Okay.
And then I'm wondering,
Yeah. Yeah, so the thing is, can we try and do stuff to make it add up to 2023? Okay. And so this is one of those kind of questions where like you really have to like you have to be ready to fight, okay? You can't just sit there and be like, numbers. Like you have to write down numbers and you have to add them up, you have to check the conditions, you have to write more numbers, okay? So one thing is you could try is, so 2023 is a very big number, yeah? You could try and get it for a small number, yeah? So you could try all sorts of things. Like 2023 is actually 17 squared times 7 or something like that, yeah? So you can actually try and see if you can get it to add up to 17, right? Yeah?
Yeah.
You can try a lot of things, okay? And then if you try a lot of things and you have really clever ideas and you still can't do it, then you might say it's impossible, right? Or you have evidence that it's impossible, right? But you wouldn't like just say it's impossible or it's possible at the start. Does that make sense?
Yeah.
It doesn't make sense to come to that conclusion at the start when you don't know anything. You don't understand the question even, right? What's the point of saying yes or no at the start? Yeah? But this is the problem that I have a lot. When I ask people these questions, they just say yes very quickly and then I get annoyed. Okay? Because there's no way you can know yes or no that quickly. Yeah? Okay? Not for sure anyway. Yeah? You could be right, but being right doesn't mean anything if you're not sure. Okay? Alright, so yeah, so I don't have time to take you through the whole process, but I can tell you sort of a very nice idea. Okay? I'll give you a very nice idea. Okay? So, can you see that if I look at the number 18, right?
Yes.
Can you see it's a multiple of 3? Yes? Okay, do you know what that means? Multiple of 3?
So 6 times 3.
It's divisible by 3, right?
Yeah.
Okay, let me try to put some other numbers on itself. So I have like 1, let me start with like 3, okay? And then here I have like 2 times 3 is 6, yeah? And here I have like 5 times 6 is 30. And then 30 times 2 is 60. 60 divided by 5 is 12. Yeah? 12 divided by 2 is 6. 6 divided by 2 is 3. Yeah, so that's another combination that works, yeah?
Yeah, but the rule to this by 2.
This is all divisible by 3, right?
Yeah, 2023 is not.
Yeah.
Okay, and 2023, can you tell it's not divisible by 3?
Yeah. Yeah.
How do you know it?
If you add up digits in the number,
It's not divisible by, it's a 7, right?
yeah, it's 7.
Okay. So this is divisible by 3, this is divisible by 3, 2023 is not divisible by 3.
7 is prime.
Yeah, 7 is prime, yeah? 17 is also prime. Okay, so this is the key idea here. It seems like all the things you get, so if you do lots of examples, you'll notice that whatever you add them up, they actually add up to a multiple of 3. Okay? And so if 2023 is not a multiple of 3, then it can't add up to 2023, right?
Yeah.
That's pretty cool, right? So how do we prove that it's always a multiple of 3? Well, so this is a little bit trickier, okay? So let me give you a rough idea first. So if I have a number like, let's call this number x, yeah? And this number is twice x, so twice x we write 2x, yeah? Okay, and then this other number is like, let's call this other number like y, yeah? Does that make sense?
Yes.
And 5 times that number is 5y. Okay? That makes sense?
Yes.
Can you see what I get if I added these numbers together? Yeah, so 5y plus y is 6y, yeah?
6y and then
Yeah?
3x.
6y plus 3x, yeah? That makes sense? Six y plus 3x, yeah? Okay. Now, if you have 6y plus 3x, see 6y is a multiple of 3, right?
Yeah.
Yeah? 3x is a multiple of 3, yeah?
Yeah.
So can you see when you add them up, there's going to be a multiple of 3?
Yeah.
Yeah? Does that make sense? So can you see, that means that if I just pair the numbers up, because there has to be twice each other, right? Or 5 times. So it's either going to be x and 2x, or it's going to be y and 5y. Yeah? Right?
Yeah.
And so when I add them up, it's always going to be either 6y or 3x. Right? Yeah?
Yeah.
So that means they're all going to be multiples of 3, and when I add them all up, it's still going to be a multiple of 3. Right?
Yeah.
Okay. Okay, and can you see that? So does that solve the problem? That's my question. Have I missed anything, or does that actually solve the problem? Okay, I'll give you like a minute to think about this. Okay,
That solves the problem.
well, that's a very announcement, very confident announcement.
Very surprising.
It basically solves the problem because 2023 is not divisible by 3. And if we use this pairing up, that means all the numbers have to be. That means the numbers have to be.
These are numbers.
That means the numbers on the circle have to be divisible by 3. 3. And
Yeah,
yeah, I feel like there's only one way to.
Alright, what did Lucas say?
He did not hear you because he was in the toilet.
Oh.
The teacher. The person teacher.
Okay, so you guys think that solves the problem? Okay, so this is the point I want to make. Okay, so this is why we do proof. Okay, so proof is about being absolutely sure. So the thing that we actually missed, okay, is how do you know that they pair up? Yeah, because for it to pair up, right, it means there has to be an even number of them on the circle, right? How do we know there's not an odd number? Do you know what I'm talking about? Like, what if there's like a 6, like, what if there's a 7 here? Yeah, you know what I mean? Then you couldn't pair the 7 with anything. Yeah? So how do we know that there's an even number of numbers around the circle? Or maybe there's not an even number and we have to come up with another argument, right? But if there is an even number of numbers around the circle, then we win, right? We just pair them up and it's all a multiple of 3. Yeah?
Can't you just, like, if there's an odd amount, can't you just put, like, one group of, like, one group of 3 numbers? Because,
Okay. I guess you could, what if you get like, you might have like 13x, yeah? Oh. Okay, so this is a tricky thing, right? Okay, so let me put some more numbers up around. Put another circle here.
wait, so can't it just be, like, a number divisible by 3 plus any other number that it's in?
Yeah, so the question is, are you allowed to even fit in a number here, right? So you look at 2, okay, if I 2 times 2 by 5, I get 10, yeah? I times 10 by 3, I get 30.
10 times 3.
Oh, sorry, by 2, I get 20. And then 20, I can divide by 5 to get 4. Yeah? 4, I can divide by 2 to get 2. Yeah? So that's okay, that's not actually 5 numbers, but that's the same 2 as that one, right? I can probably just insert another number here for fun. Make that a 4. Yeah? This is still 6 numbers, yeah?
Is it possible to have it?
That's a good question, okay? So in fact, okay, it is not possible to have an odd number. Okay? So let me show you why, okay? So if you look at the number 2, so this is something quite advanced. It's called modular arithmetic. But in terms of for you guys, it's just remainders. Do you guys know about remainders?
Yeah.
Okay, so if I divide a number by 3, right? What can the remainder be?
I see a 2 or a 1.
Or 0, right? Okay. The remainder could be 1, 2, or 0. Does that make sense?
Yeah.
Okay, so if I divide this number by 3, what's the remainder?
2.
2, yeah? Well, if I divide the next number, what is it?
1.
1, yeah? So if I divide this one by 3, what's the remainder?
2.
2, yeah? If I divide this number by 3,
1.
what's the remainder?
1.
Yeah? What about this one?
2.
2, yeah? What about this one?
1.
1. So can you see that, like, well, can you see a pattern? It's just 2, 1, 2, 1, 2, 1, right?
Yeah.
Okay. And you can actually explain that, okay? Because if you have a number that starts with 2, right?
Yeah.
If you times it by 2, right? Yeah? It's going to have a remainder 2. Yeah? If you times it by 5, it's also going to have a remainder 2. Does that make sense? Does that make sense?
Yeah.
So you have a number, it's equal to 3 times something, right?
The remainder is basically just double.
Yeah, it's a 3 times something plus 1, right?
The number's double
Yeah.
than the remainder.
If you times this by 2, when you times the 6n by 2, that's still 3 times something, right? So when you double the number, the remainder just doubles. Yeah? When you times it by 5, the 5 times 3n is still multiple of 3, right? So it's 5 times 1 is going to... So the remainder becomes like times by 5 as well, right? But 5 is 3 plus 2, right? 5 is 3 plus 2.
Yeah.
So then the remainder becomes 2 when you times by 5. Yeah?
Yes.
Okay. So basically, if a number is times by 2 or 5, the remainder goes from 1 to 2. Yeah? Okay. And can you see it also goes from 2 to 1, right? Because you times 2 by 2, you get 4. And 4 has remainder 1 when you divide by 3. Yeah? Does that make sense? So, and if you times by 2 by 5, you get 10, right? And 10 has 1 when you divide by 3. Yeah? So no matter which way you times 2 or 5, they're going to change the remainder. Okay? So that means if this is a 2 and this is a 10, that's going to be 2 and that's going to have remainder 1, right? And then no matter what the relationship is, their remainders will be different. Yeah? Okay? So that means if it's 2, 1, 2, 1, 2, 1, right? It has to end back on a 2, right?
So if it were odd, that means it would be 2, 2.
Exactly. Yes. Beautiful. That's exactly the reason. Yes. So if it was odd, it would go back onto 2, right? It will not go back onto 2. But it has to go back onto 2, right?
Yeah.
So then it's even. That's very good. Yes, very good.
What would be 1, 1?
That's some scared.
What?
Yeah, that was the jump scare as well.
Yeah. You know why you were scared, right? Because you were sleeping and then someone woke you up, right?
No, I wasn't scared because I wasn't listening.
Yeah. Yeah, exactly. So, and I don't think you were scared because you were kind of listening, but you two were kind of sleeping. Yes.
I wasn't watching it.
You weren't watching at all. Okay.
Predicting your reaction.
Okay. Yeah. So can you see that shows there has to be an even number of things on the circle? Yeah. And if there's an even number of things on the circle, you can pair them up in twos. Yeah. That's what even means. Yeah. And if you pair them up in twos, each one is a multiple of 3, right? So when you add them all up, it's a multiple of 3. Yeah?
Yeah.
And 2023 is not a multiple of 3.
Can't work.
It can't work, yeah?
2023.
So that's amazing, right? Like it's like you can prove that no matter how hard you try, no matter how smart you are, no matter how many numbers you put on the circle, you can never get 2023. I'm saying?
2023 is more than 2023 times 1 is
Thanks, Michelle. Thanks. See, your comment is no longer very good because you weren't listening, right? Yeah. Okay, so we don't have enough time to do the last one, okay? But it's actually a very interesting thing to think about, okay? Because, see, what happens is, at your age, right, when you do this kind of problems, it's a little bit, see, if you just encounter problem 2, okay, I think you have a lot of trouble because you don't know what the word convex means when you first see it, and you don't know what the symbols here mean. So, like, question 2 is kind of hard for different reasons than maybe what's the problem meant to be, right?
Do you think it's possible for kindergarten to solve one of these questions?
It's definitely possible, but it's like a 1 in a million kindergarten, not like every kindergarten, you know? So the average kindergarten student would have no chance to solve any of these problems, you know? The top kindergarten student in the country probably could, yeah?
How about in the world?
Like definitely. I mean, if the top in the country can do it, the top in the world can do it too, right? Okay.
Top in the world can do too.
Yeah. No, like top in the world is not what you think. You have to like there's like 7 billion people in the world. You know what I mean? So like, you know, like it's like who's the tallest kindergarten student in the world? Like, is there someone in kindergarten
Who's the oldest kindergarten in the world?
Repeating kindergarten every year. Failing kindergarten. Yeah.
Starting
Yeah.
kindergarten at 29.
Yeah. Okay, so the point I'm trying to make is
Starting kindergarten at age 100.
yeah.
Imagine starting kindergarten when you failed until
Yeah, and also one of the reasons why like kindergarten people can't do this also is because they can't concentrate for more than like 30 minutes. Okay, so to really do this, you need about 4 hours. Okay, and
I wasn't even concentrating the whole time.
yeah, you stopped concentrating as soon as we started.
No, like
Yeah.
average TikTok scrollers, there's kindergarten, there's concentration better than like TikTok scrollers. They can concentrate for
Yeah.
at max 2 seconds.
At max 2, yeah, exactly.
TikTok scrollers.
Exactly. All these like YouTube, iPad, TikTok, they just make you concentrate badly, right? Because anytime you think you just scroll, it's really bad. Okay, so
If this was a YouTube video, everyone would just
but these questions are good because see these ones you don't really need to know anything to understand what it's asking you, right? It's a bit logic intensive, but in terms of words, like I mean you know most of the words, right? The hardest word here is maybe like integer, which means whole number. Okay, so the last question, I think you can actually understand the question, but it's actually a hard question even if you understand it. Okay, so they're playing a game, okay, and they got bricks, and they're trying to stack bricks on top of each other. Okay.
Bricks, yummy.
And so there's 50 black bricks and 50 white bricks, and you're only allowed to put black bricks on top of the white bricks. But then once you got stacks of 2, you can actually put the entire stack of 2 on top of another stack. okay? But you have to make sure it's black, white on the stack, okay? And the question asks you, who will win the game, okay, if Alice moves first and then Bob moves second, and whoever can't move loses, yeah? So if all the things are like black on black, you can't. If you have to put black on black, then you lose, right? Okay. So that's something I think you should think about a bit more. And I can send you a video of the solution, or we can guess it in class if you're really interested. But that's something you should go to think about for a long time. Okay.
Just like a
Yeah. So this brick. Yeah. 5 minutes is unfortunately not enough time to actually. I had something planned for this question, but I think let's just end it there, okay? So, alright, don't.
You press the
Hi, I'm sending down. Alright, guys, if you're interested, you can look at this question at home, okay? So this kind of question, I don't want you to be like, oh, I've solved it, I'm finished. So like, I want you to spend time because I think no matter how you think you solved it, from experience, you probably didn't solve it, okay? So part of the kind of the difficulty in maths is thinking you've solved it when you haven't, okay? And so I would rather, if you want to spend time on this, it's to spend the time to think about the problem instead of thinking, oh, I finish it or I don't finish it, yeah? Because the finish doesn't mean anything because most people who finish it, it's wrong anyway, right? They just spent less time, okay? So, so it's actually for the stronger students, they realize they haven't solved it for, and so most of the time it's actually better to know that you haven't finished it because then you know you don't actually think you're right when you're wrong. Okay. All right. Okay. Let's end it there. You have a soccer game to go to, I think, and so Lucas, Blake, I'm going now. Okay. So we'll see you guys next week.
Bye.
All right. Bye.
time for the kindergarten to vomit.
Yeah.
Average kindergarten brain. Average kindergarten. Average kindergarten. Below average kindergarten.
Oh.